Today I'm going to talk about flooding and the physical and human causes that lead to flooding. So firstly, we should start with a definition of what flooding is. This is where the amount of water that's moving down the river exceeds the river capacity. So we can see in this picture here that what has happened is there's been an influx of water from whatever cause, often from heavy rainfall, and the water that was in the channel is too much for the channel to hold, and therefore it is moved out onto the surrounding area. So the most important thing to think of in terms of flooding is that most flooding is related to spells of heavy rainfall. But the critical factor really is how quickly that rainfall gets onto the land and reaches the river. And this is where we talk about lag time. If that time from where we're raining really heavily to getting to the river is really short, that means it's moving quickly to the river. That means we've got a higher chance of flooding occurring. So when looking at the causes of flooding, we can look at it from two different distinct areas. We can look at the physical factors. So this is to do with nature, where we're talking about things such as the weather, the rock type, soil, type of relief of the land. But you can also look at the human factors, things that humans have done to maybe exacerbate certain conditions. And I'm going to look at them both now in detail and how they affect and cause flooding. So one of the physical factors we can look at that will affect flooding is the geology. This is the rock type. So here is a granite outcrop, and granite is impermeable. That means water doesn't pass through it. So if we have impermeable rock and we have water from rainfall falling onto it, what we would get is this would happen. Because it's impermeable, we would get low percolation. That means the water can't go through the rock. And because we've got low percolation, we get high surface runoff. It goes over the surface. And because of that, this therefore affects flooding. That means the water is getting to the river quickly. That means there's a short lag time. And because of that, we have a higher chance of flooding occurring. However, if we had a rock like chalk is permeable, it's got these large spaces between the grains, and that enables water to pass through it easily. If we're able to pass through it easily, that means we get more percolation of the water downwards, and if we get more percolation, that means it takes longer to get to the river, a longer lag time. If the water is taking longer to get to the river, that means we have less flooding. The next physical factor we need to consider is vegetation. On this picture on the left, we have a heavily forested area with a large canopy. If we had rain fall onto this area, then the raindrops would be intercepted by the leaves. This area would have a high interception rate, and that would affect flooding in the following ways. It would mean that those raindrops don't make it directly to the ground really quickly. It would slow the water down, and that means when the water's slowed down, it has the chance to infiltrate into the ground, and therefore we don't get that much surface runoff. So we get a less of surface runoff, and if we get less surface runoff, the water isn't getting as quickly to the river, and therefore we're going to get less flooding. However, in this second picture, we have no barrier, so we have no interception. What that leads to is that means the water can directly hit the surface and just run off, but it also means if it does infiltrate, then that ground will get saturated much quicker because there's nothing stopping it or slowing it down. And both of these factors mean that we're going to have much higher surface runoff rates, and therefore we have a higher chance of flooding as the water gets to the river very quickly. Another physical factor is the drainage density. That means if we've got these two catchment areas, these two drainage basins, it's the kind of total length of all the rivers in that kind of area. So if we look on this one on the left, it's very low in terms of the amount of rivers that are in there that are contributing to this main river, which I'm highlighting here. I'm going to highlight it on the same picture on the right. So we can see there's very few tributaries and streams that are adding to this main stream. But we can see on this right one, there are lots and lots and lots and lots of tributaries that are adding in. If we've got a high drainage density, that means we're going to have lots of tributaries adding water, and therefore it's going to get quickly into the main channel. So that river that I've highlighted as yellow, we're going to have lots of water getting into that main channel from all these different sources, and therefore it's going to be likely to flood easily. Another factor to consider is the physical shape of the land, so the relief. Here we have got some very steep slopes. That's going to affect flooding in this way. We're going to have rapid runoff because it's moving down the slope very quickly, and because of that the water gets to the river quickly, so we're going to have shorter lag time and increased chances of flooding. Another physical factor to consider is the soil type and the permeability of that soil. So at one end we have sand, which is very permeable. That means the water can pass through it very easily. But at the other end we've got something like clay, which is pretty much impermeable. The spaces between the grains are very, very small, so water can't pass through it very well. That means we don't get very much infiltration. And because we don't get very much infiltration, it means we get lots of surface runoff. And as we've said before, that means the water gets to the river very quickly, and therefore we get flooding. Weather is another physical factor that can affect the amount of flooding. When we get a period of heavy rainfall, the ground is a bit like a sponge. It can only take so much. So if the rainfall is so heavy that the ground can't absorb any more water, then that water will appear on the surface and flood. And that's what we call reaching the infiltration capacity. So each bit of soil has a certain capacity to infiltrate certain amounts of water, but once that is reached, then the ground won't be able to soak anymore, and it will obviously mean that the water will flood on the surface. We can also have a change in the weather in terms of temperature. So as we can see in this picture, we have lots of snow which is accumulated over the winter, but when that temperature changes, when we get into springtime, all of that snow will suddenly start to melt, and that means it will run off into the river. And as you get a sudden increase in lots of water moving from the snow into the river, you will get the capacity exceeded, and therefore you can get flooding in those spring months. Now we can look at some of the human factors that cause flooding. One of the major human factors would be urbanisation in two different ways. So on our right picture here, we've got impermeable concrete. As we know, with any impermeable surface, that would increase surface runoff. On our left here, we've got gutters and drains. That means any water that's caught by buildings would go straight to the river rather than being kind of diverted in any way. These both lead to the water getting delivered straight to the river very, very quickly. So it's a quick delivery of the water. This is obviously a shorter lag time, and when we get a shorter lag time, therefore we get increased flooding. Another human factor that is often common is when we deforest areas. Deforesting an area will mean there is less trees, and when there is less trees, we have less interception by the leaves and the canopy. When we have less of the interception, the water isn't slowed down, and so it's hitting the surface directly and running off, so we get more surface runoff, and when we get more surface runoff, we get increased flooding. When we convert the agriculture, we often get an increase in flooding. This is because of two reasons. When we have bare soil, it has very low interception rates, and often infiltration is difficult, and therefore we get flooding. Also, when we plough down a hill, it actually funnels the water towards the channel much quicker, and therefore we get an increase in surface runoff and therefore an increase in flooding. The last factor to consider is burning fossil fuels. As we do this, more CO2 is put into the air. This enhances the greenhouse effect artificially, and that means temperatures rise globally. With this will affect flooding in the way that it will melt more ice and glaciers, and therefore we'll have more snow melt running off into rivers. But it will also get increased rainfall at certain places in the world, and also more storms, which will bring intense rainfall, which will cause flooding to happen on a regular basis.